Today we are talking about weathering. So the first type of weathering we're going to talk about is mechanical or physical weathering. So this is like a physical change in chemistry. So this is an actual tearing the rocks apart by cracking and prying. It's creating smaller rock fragments and sediments, but it is not changing the chemical composition of the rock. So that is the key of physical weathering, that it does not change the chemical composition of the rocks. So the first kind of physical weathering that we're going to talk about is frost wedging or ice wedging. So as water gets down in the cracks of rocks, and as water freezes, it expands. And so when it expands, it pushes the rock pieces apart. And then that process can repeat. The water will melt. There are new cracks, as you can see here, that formed. And so the water can get into those new cracks and then freeze again and push off other pieces of rock. So this occurs in areas where there is enough moisture and where it gets cold enough to freeze and thaw repeatedly. So areas like the mountains, especially like the mountains in North Carolina, the Appalachians. The next kind of mechanical weathering that we're going to talk about is exfoliation. So sheets of rock are peeling off of a rock face. So you can see here these little pieces of rock are peeling off of the rock face. It gives the rock a stepped appearance. And those rocks are breaking off parallel to the rock face. So it's those sheets of rock that are falling off. So this is most common in igneous rocks like granite, and it occurs mostly in mountainous areas because you need that gravity to pull those pieces of rock down. So the next type is thermal expansion. So that is when crystals of the rock itself expand and contract as they heat and cool. So expansion, when it heats up, it will expand. Then when it cools, it'll contract, and those repeated expansions and contractions will push the minerals grains apart. So this is going to occur mostly in environments where there are extreme temperatures like the desert. Then we have crystal growth. So salt crystals can grow in the cracks and the pores of rocks. So here we have lots of open pore space in between these rocks, or these rock particles. And so salt crystals, once water evaporates, salt crystals will grow and grow and grow, and they will eventually push the rock grains apart. So this occurs where there is a supply of salt water, so places like the ocean and the desert, where there's a lot of evaporation and all the salts from groundwater can have a chance to grow in the rocks. And then we have tree roots or root wedging. So the teeny tiny tips of plant roots can get into teeny tiny cracks, and then those roots grow and they push those cracks apart. And eventually it'll break the rock into smaller pieces. So we have as the tree is growing, it's pushing those pieces of rock apart. This is mostly going to happen where the environment can support tree growth. So areas that are more moist and that have good soil. And root wedging is most likely to happen in dense forests. And then the last type of physical weathering is abrasion. So abrasion is when other rocks or sediments scrape pieces off of the larger rock face. So you either need wind or water to actually transport those sediments, and it will come and blow, and those sediments will be forced to rub up against the rock face, being pushed by either wind or water. And so it will create smaller pieces of sediment. So this occurs in harsh environments, such as high elevations where the peaks are exposed to winds, windy areas, arid regions like the desert where there's pretty high wind, river corridors where you have a lot of water rushing by, and tidal areas where you have the waves crashing. All right, next we're going to move on to talk about chemical weathering. So chemical weathering is a chemical reaction that breaks down the rocks. So the key point of chemical weathering is that the chemical composition of the product of chemical weathering is different than the parent material. So again, the key point of chemical weathering is that the chemical composition of the product of chemical weathering is different than the parent material. So we only have 3 kinds of chemical weathering. The first one is dissolution. So this is when minerals in the rock dissolve into solution when it comes in contact with water, just like salt dissolves into its ions when you put it in water. So this is how the salt got into salt water. This creates caves by dissolving limestone. So you can see how these little cavities were formed in this rock because the minerals dissolved when the water came in contact with it. This is going to happen mostly in moist regions because you obviously have to have water to have dissolution. The next one is oxidation. So we're all pretty familiar with oxidation in the form of rust. So the metallic cations in rocks can rust. And a lot of times these cations in the rocks are the cement that are holding pieces of sediment together to make sedimentary rocks, or holding the pieces of metamorphic rocks together. And so if those glues rust and fall apart, then the sediments will no longer be adhered and they will fall apart as well. So this is indicated by reddish stains on the rocks. And it occurs very quickly in warm, moist climates, but it also occurs in cold, moist climates just a little bit more slowly. And the last time is hydrolysis. So this is when a hydrogen or a hydroxide ion from the water displaces the ions in the minerals and forms a new mineral. So this happens a lot in feldspar. And so one product that we get from one very common product that we get from hydrolysis is clays, which is a very important component in soils. So when the water gets in, it actually changes the compounds in the mineral and forms clays. So again, this occurs commonly in feldspar rocks and in moist climates. All right, so those are our types of weathering. Tomorrow in class, we will talk more in detail about